Hello and welcome to Math Lessons with Linda. Today's topic is the rational root theorem. This lesson today is following a lesson on Descartes' rule of signs. If you have not already talked about that in your math class or watched that video, I suggest you pause here and go back and look at that before you begin. We're using the same function to pick up with the problem we did previously. Our function that we're using is f of x equals 4x to the third minus 9x squared plus 6x minus 1. This function is one that we determined previously how many positive or negative roots I could have in my function. For the positive roots, we discovered that there are potentially 3 or 1 number of positive real roots. And we also determined that for negative roots, there were none. What that tells me is when I'm using my rational root theorem to figure out exactly what the roots are, I don't have to test any of my negative values that I find because those are not an option for this function. In the rational root theorem, we are going to use the leading coefficient and the constant term at the end. We are going to label the constant at the end as P and the coefficient at the beginning as Q. If you want to find all the possible roots that you can have that are real roots for this function, we are going to find all of the possible combinations of the factors of P over the factors of Q. So what I'll do is I'll first find all the factors of P and all the factors of Q and combine them together to figure out what my potential factors would be. So for P, since it's 1, I only have factors of positive 1 and negative 1 for P. For Q, which is 4, there's a few more. Plus or minus 1 is a factor. Plus or minus 2 is a factor. And plus or minus 4 is a factor. So my next step is to take this factor for P and combine it with each of the ones for Q. That's going to give me plus or minus 1 over 1, which is 1, plus or minus 1 over 2, so a half, and plus or minus 1 over 4. So as we noted before, we don't even need to test these negative values. So we're only going to be testing the positive 1, the positive 2, and the positive 1 over 4. Those are the ones that are potentially going to be our real roots. I'm going to begin with 1. So how do I test it? I test it by using synthetic division to see whether or not I get a 0 remainder. So for synthetic division, I'm going to take my root, which is positive 1. I'm going to take all of my coefficients from my polynomial, and I'm going to divide. So in order to do that, we drop down the 4 and multiply each of these by what the number is in the box, in this case, the 1. So 4 times 1 is 4. I'm going to add going down, so I get negative 5. Multiply that again by 1, I get negative 5. Add them down, I have a 1. Last time to multiply is a positive 1, and I get a 0. This is what I want, because what that tells me is that x equals 1 is a factor of my polynomial function. So I have found 1 out of potentially maybe 3 positive roots. So how do I find the other ones? Well, remember that the coefficients that you have here are now your new polynomial. So I now have a 4x squared minus a 5x plus a 1. So when I do this by factoring, you can either use the AC method or you can use the guess and check method. I'm going to go ahead and factor this out for us. 4x minus 1 times x minus 1 is how this polynomial factors out. I'm going to take each of these and set them equal to 0. These are going to give me my other two roots. So the 4x minus 1 equals 0 gives me x equals 1/4. And this other factor gives me another x equals 1. Recall that we already had an x equals 1. So right here, I've got a double root. This counts for 2 of the roots in my function. I have a 1/4. And if we go back up to the very top, we knew we could have potentially 3 positive roots, which in this case, we have 3 real roots, including our double root, and we have used the rational root theorem to find all of the roots for our polynomial.